Welcome back to another hands-on Kafka Connect exercise where we'll be using the Confluent Cloud Connector API. Before we dive in though, you first need to do a bit of preparation to make sure you have all of the tools that you need. If you don't already have a Confluent Cloud account, make sure to go ahead and do that now. Confluent Cloud APIs are a core building block of Confluent Cloud. You can use them to manage your own account or to integrate Confluent into your product. The goal of this exercise is to demonstrate various Confluent Connect API REST calls that can be used to create, configure, and monitor Confluent-managed connectors running in Confluent Cloud. We will also use the org API to identify the cluster ID for the KC101 cluster, as well as the cluster API to create a Kafka topic that will be streaming data into and out of. We'll start off by using the Confluent Cloud org API. This requires a Confluent Cloud API key, which we'll generate using the Confluent CLI. But first, we'll need to log into Confluent Cloud. And note that we're using the save flag so that our credentials will be used for subsequent commands in this exercise. They'll remain active until you run the logout command. Like we saw in the setup instructions, we can generate a new API key here using the following. Next, we'll convert the API key and secret to a base 64 encoded string. This string is used in the authorization header that will be included in the REST calls to the Confluent Cloud API. At the same time, we'll assign this string to an environment variable, which will make it easier to submit the REST calls during the rest of this exercise. We need to also convert the KC101 cluster API key and secret to a base 64 encoded string, again, to use this in the authorization header for REST calls to the cluster API. This will be slightly easier since we can reference the environment variables created earlier from the Java config file. Now we're ready to issue REST calls to both Confluent Cloud Control Plane APIs as well as cluster APIs. Let's first list our environments by issuing a REST call to the org API. Locate the default environment in the response and note its ID. Using this ID, we can now obtain the ID for the KC101 cluster. Again, note the cluster ID field in the response. Using this ID, we can now create a new Kafka topic named transactions. We'll set this as a target for the DataGen source connector. Notice we need the cluster API for this REST call, which is why we're using the cluster authorization string instead of the cloud authorization string used on the previous commands. Before proceeding, we should take a moment to verify that the transactions topic was created successfully. And before we create the DataGen source connector instance, it's always a good idea to list the fully managed connector plugins that are available to us for streaming using our Confluent Cloud environment. Note that this list may be a little different depending upon which cloud provider Confluent Cloud is running in, and that's why it's always good to check. It can be a bit difficult to spot the different plugins in the command output. For our sanity, let's run the command again and pipe the output to the JQ command to get it in a friendlier format. All right, now we can actually tell which individual plugins are available. As you can see, the list is quite long, but it does include the DataGen source connector that we're familiar with. Let's create a DataGen source connector instance using the API. To do so, we use a put or post REST call. Put is somewhat easier because it will create the connector if it doesn't already exist, or update it if it does. If it already exists and there's no update to make, it won't error out. So put is the idempotent way of updating the connector. To verify the connector instance's status, let's first list all connector instances in the cluster. And using that, we can check the status of the specific DataGen connector instance we just created. The current status is provisioning. This is expected as it takes a moment for the connector instance to be fully provisioned and up and running. Before we continue, it's a good idea to repeat this command a few times until we see the status has changed to running. Once the status shows the connector instance is running, we can consume records from the destination topic to verify that sample data is being produced as expected. After allowing the connector to run for a little while, we should now have a decent amount of sample data in the transactions topic. So that we don't unnecessarily exhaust any Confluent Cloud promotional credits, we can go ahead and delete the DataGen source connector instance. So by this point, we've set up the beginning of our data pipeline. We made a connector to generate data to a Kafka topic. Next, we can establish the downstream side of our pipeline by setting up a MySQL sync connector. This connector will consume records from the transactions topic and write them out to a corresponding table in our MySQL database that's running in the local Docker container that we started during the exercise environment setup steps. Let's take a look at the request we'll be using to set up this connector. There are a few things to note. First of all, the SSL mode is set to prefer. This configuration parameter tells Confluent Cloud to connect using TLS if the destination host is set up to do so. Otherwise, a plain text connection will be established. For this demonstration, the local host is an AWS EC2 instance that does not have TLS set up, so the connection will be non-secure and the sample data will be unencrypted across the wire. In a production environment, we would want to be sure to set up the destination host to support TLS. Next up, notice the connection host. This is the public endpoint address assigned to the AWS EC2 instance. This value is shown in the AWS console display of the EC2 instance details. Now we can continue by running the curl command. After that command is executed, we should check the status of the connector instance we just created. We see the status of provisioning and need to wait for the status to be running before we continue. Again, we'll check it a few more times just to be sure. Once the status shows the connector instance is running, we can run a query on the MySQL database to verify the connector has written records to the transactions table. And that's a success. Let's continue with our tour of the Confluent Cloud API. Another useful command allows us to inspect the config for a given connector as follows. There are also use cases where you might need to pause a connector instance temporarily, either for debugging or maintenance purposes. As always, it's good to verify both the connector and task are paused after running this. We can use the status command to check this just as before. Confirmed. To round out the tour, we can now resume the connector and its task. And finally, let's verify that both the connector and task are again running. Everything's up and in the running state. So that wraps up our tour of the REST API. Note that if you run this demonstration yourself, you'll need to tear down the environment after doing so, just to avoid unnecessarily accruing cost to the point that your promotional credits are exhausted. And just to be sure, let's walk through that teardown process now for this environment. First things first, we should delete the sync connector. Since there's no running source connector, we're safe to go ahead and delete the transactions topic. And finally, we'll shut down the MySQL Docker container and free its resources. And with that, you've completed the exercise and should have a decent idea of the Confluent Cloud Connector API and the various commands available to you through it. See you in the next module where we'll continue learning about Kafka Connect.